So let's take our skills to the next level and examine a more complex starter schematic that uses a relay in the path to the S terminal in order to allow a module the ability to inhibit the starter from starting in case there's a security issue or something else wrong with the system. First, let's notice the similarities to some of the other schematics we've already looked at. We have the battery, we have the starter, and notice the pull-in and hold-in windings and the motor itself. It doesn't have to be drawn the same, but once you recognize or know what to look for, you'll find that it doesn't matter as much how they draw it. Notice the ground symbol's a little different than some of the ones we've seen before, but we still have the switch inside the solenoid, and we have the two coils, the pull-in and hold-in. We have an ignition switch that we're turning to the start position, just like in the other schematics. And we have a park neutral position switch that only allows the car to start or crank if the car is in park or neutral. Now, some of the differences would be that we now have a powertrain control module in the picture, and the powertrain control module's job is to give a ground to this starter relay up here. And when the starter relay switch gets closed, then the power from the ignition fuse over here, the 40 amp ignition fuse, then allows power to go to the S terminal of the starter. Another difference we see here in this schematic is that the park neutral switch and the ignition switch are not in series. In the other pictures, we've had them where they're in series in the path to the S terminal. In this case, we have the park neutral switch in series with the coil side of the relay, and then the PCM, or powertrain control module, when it closes this internal switch to allow the starter relay to activate, then we get power to the S terminal. In this picture, we're using an information circuit just to let the PCM, or powertrain control module, know that we are cranking the car. And just like we learned in the information circuits video, it's just a power load and ground circuit. This is a power side switch information circuit where the load is the resistor inside the module, the ground is inside the module, and all of this above that resistor is the power side of the circuit. When the switch is closed, the 12 volts then gets down to this location, and where it says here crank voltage, there's an internal voltmeter monitoring when it sees 12 volts. So when it does see 12 volts at this location, the PCM knows that the key is in the start position. And that may be one of the criteria that the PCM needs to see in order for it to want to close the starter enable relay control switch. There may also be other things like signals from the security system or theft deterrent system letting it know it's okay. And in some schematics, it may be a signal from another module, a body control module, or a theft deterrent module. In its simplest form, we're just using an information circuit here to monitor the voltage so that we know when the ignition switch is turned to the start position. One other thing to note on this particular schematic is that the fuse box under hood, notice up here, there's the fuse box under hood, which is drawn up here. The dashed line is kind of highlighting that. And down here, it also says fuse box under hood. And then there's the box around here, dashed box. And remember, we learned in the beginner video that the dashed boxes signify that there are a lot of other wires in the fuse box, and we're only showing the ones that pertain to the starter schematic. But here they're drawing the fuse box in two separate locations, but it's the same fuse box. And this is something that's done on some manufacturers will do this, where they draw the fuse box twice just so that they can get the layout of the wiring to look neater. Because the wiring goes from the fuse box, it goes to the ignition switch, and then it goes back through the fuse box before it goes to the powertrain control module. So instead of making the wiring circle back around, they draw the fuse box twice on the page, and the dash box for the both locations there are telling you that it's the same component, but they've just drawn it two times and that they're not including all the wiring. So what makes these more complex schematics a little bit more difficult to diagnose is that there's more circuits in them. We have the information circuit for the PCM. We have the coil side of the relay. We have power, load, and ground for that. We have power, load, and ground for the pull-in coil and the hold-in coil. And then we have the power, load, and ground for the starter motor. In the next video, we'll highlight these so that we can identify them and have the picture be clearer in our heads of which parts of the schematic are power, load, and ground. And after that, we'll do a case study or two to help us understand how the diagnostic process would unfold.